Hey, welcome back to another lecture in Python. Um, so what we're going to be talking about for this lecture is another really key concept for programming in general. This is what makes programs think, so to speak, and that is the idea of conditional statements. So what is a conditional statement? It's making a choice to do something versus one thing versus another. We do this all the time, obviously, and naturally, it's important that programs can do the same. That's how we get programs that function as though they, can think and things like that. So far, at least in all the programming we've done, everything you've done has been sort of deterministic, right? You know exactly what it's going to do when you hit play, and you're just watching for the program to do it. The biggest sort of change ability that we've put into the program was being able to take a user input at the console. But let's learn how to make the program start to make some of the decisions for itself. So the most basic thing we can do here is let's define two variables, var1 equals 5 and var2 equals 10. And now let's compare those two variables with the code and make the computer pick which one is bigger. So how we're going to do that is with something called an if statement. And the syntax is rather simple. We will say if, and then you get a nice little parentheses to show what you're going to ask. We will say if var1 is greater than var2, and after you've decided what you're going to write for your check, you will do a colon and then press enter. And my IDE, PyCharm, is smart enough to know that you have to do a tab here. There's two key things that you have to remember to do here, which is to put this colon and tab what comes next. In many other programming languages, like C-based languages, you will see something that's written like this. If something, then you put this some brackets, and you have to have opening and closing brackets, otherwise your program won't work. Since Python doesn't have brackets for this statement here, the only way it knows that you are still inside of the if statement is these tabs. This is why I'd mentioned before that most programming languages don't really care about white space, and Python kind of doesn't, with a few special cases. These are the special cases. Python cares about the white space at the start of a line because it tells Python if you are still inside of this if statement. And what do I mean by inside? When Python gets to this line, it will come see this, oh, if, I know that's a special command. So if something in here, it's going to do a check, and if it finds that this check is true, it will continue down these tabbed lines of code. And let's just put some comments here just so that you sort of can see. And then after it's done doing whatever is inside of that little bit of tabbed code, it will continue on and do the rest of your program. And we will do print all done. And I should add this to my other lines of code so that we, it's always good to have an indication that your program is done. But so when Python gets here and it checks if this is true, it will do these lines of code. Let's give it some functionality. Let's say print. Well, what are we checking? We are checking is var1 greater than var2. So inside of this, let's just say var1 is bigger. So it will check here, var1 is bigger than var2, and it will print that it's bigger. All right. Otherwise, it's going to get to this point where it evaluates is var1 greater than var2, and it will say, so in this case, var1 is smaller than var2, so it's going to, this is going to be false. And when it sees that this statement here is false, it will skip everything that you have tabbed. So what we expect to happen here is Python's going to come down and say var2 bigger than, is var1 bigger than var2? No. Skip, and then it's going to say done. So all we will see is done. And lo and behold, there that is. All right, so we've seen how that works. What if we want to, well, let's check if it's if it does what we think it does. Let's make var1 bigger than var2 now. And oh, there we go. var1 is bigger. Excellent. So let's set that back to not being true. What if we want to make it, what if we get something that is var1 and var2 are the same values? What is it going to do here? Well, this is a greater than, but it is not a greater than or equal. So this only evaluates true if var1 is bigger than var2. If they're the same, this is still false. So let's see if we get anything out of this. And all we get is done because they are the same. So this is false and your statement is false. So you might ask, you know, I don't have a greater than or equal sign character on my keyboard. How do I check if something is greater than or equal to? We have two ways that we can do that. First of all, how do we check if something is actually equal? Your first answer might be, well, I mean, in math, you use the equal sign, obviously, so let's just use the equal sign. But wait. We've already established that Python, when it reads these lines, comes over and says, ooh, this is equal. This is how you assign a variable. In Python, and a lot of programming languages for that matter, the equals sign doesn't mean, it is not a logic check, right? It doesn't check something, it assigns something. It doesn't mean the same thing. So in order to distinguish from a check versus a versus an assignment operation, what we have is a new operator, the double equal sign. The double equal sign in Python and most programming languages is the equality check operator. So what this says is, instead of saying, well, var1 equals var2, aka assign var2's value to var1, we are instead checking, we're doing a conditional statement, is var1 equal to var2? And if that's true, let's change this. I'm going to comment this out. Put a hashtag there. And always remember to put your tab in, otherwise you're not in the if statement anymore. var1 and var2 are equal. So now, if these two variables are the same, they are equal, and we'll get a print. Otherwise, if we make var1 something different, we get nothing because it doesn't succeed this logic check. All right. So with that in mind, knowing that we don't have a greater than operator, knowing that we don't have a greater than or equal to operator in one character, how do you think we have that functionality in Python? Well, lo and behold, they did the same thing that they did for the assignment versus equality operations, and they just made a combination, a two-character operation. So var1 is greater than or equal to var2. So you can see this little, and it doesn't work if you swap these. You can't say equal than or greater. It doesn't like that. It has to be greater than or equal to. But with that written that way, you'll see we get two outputs because we have this one here checking if it's equal, and then we have the second one here checking if it's greater than or equal to. Okay, so that's all fine and dandy. If I change this var1 to be just greater than, it will still be true at this check. Boom. So, but it won't be true at this check anymore. So, but I did say a couple minutes ago that you actually have two different ways that you can check if something is greater than or equal to. This is the more normal way that you would do that because it's sort of small. It only uses one operator. But the second way that you can do that is with a new operator that is also very, very important. And that operator is, so first of all, we'll say if it's greater than, okay, or. Wow, awesome. Python. So what does this do? In the logic, I mean, the same way we make decisions on, in real life, we say, I will get pizza for dinner if I have money, or if I want pizza or I am forced to get pizza, right? Either of those options, if either of them is true, if you're forced to get pizza, you'll get pizza. And if you want pizza, you'll get pizza, right? Either or, if either of those things are true, you will get pizza. But there is another way that you can sort of compare two things logically, and that is the and operation. So again, just like we make decisions in real life, we have I want to get pizza for dinner, but what do I need? I both need to want getting pizza and I need to have money, right? This is not either or. You need both of them to be true. And in Python, the way you express that logic is and, right? In this weird way of writing this, though, this is going to do, we don't have an operator for this is greater than or equal to, which can be rephrased with this logical statement. We don't have a greater than and equal to because it doesn't really make sense. you can't both be greater than and equal to something. So what I can put here is this is never true. So if you ever see that, something's gone wrong, right? You can't have variable 1 both be equal to and greater than, right? Never true. But what do you know? It's, if this is never true, this is a great example of, well, no, we'll just leave that. So now we print this. Obviously, both of these two logical statements, var1 greater than or equal to var2 and var1 greater than var2 or equal to var2 are the same. So these two, you should always get this to print twice if it prints, right? These two are logically the same operation. This one should never print. So what if I want to get this logical, something out of this? What I can do is use the other half of the conditional if statement. So what do I mean by that? Well, if is a yin and yang sort of situation, right? I will do this if the weather is good. Otherwise, I will stay inside, right? If generally comes with a what do I do if that's not true? And in Python, the way you express that is with the else statement, right? What this will do is do something only if this is false, right? So let's say print this is always true, right? So if we know that you can never be greater than and equal to something, that's never true. And therefore, when Python gets here, it will check and say, what is this evaluate to? It's false. So I will print this is always true. All right. So let's see if that's in fact true. There we go. We have this is always true in there. Regardless of what we set our value of var1 to, we can change the other outputs. var1 and var2 are equal. That means they're also greater than or equal to each other. And they're still not both at the same time. So our output is always, this second output is always true. That's great. So you've learned how to do comparison operators for greater than, equal to. You've learned how to join multiple true false checks using the and or operations. And notice that I'm using the word operator, which is the same word that I used for assigning things. It's also the same word I used for doing addition, subtraction. These are all operations at the most basic level. So they are functionally doing math comparisons or doing math with the values to get the outputs. So they're all, and in fact, in other languages like C, you'll find that these are all symbolic. So the and or get their own little symbols, and you can actually, talk about what it means to and two numbers together. And they use, but that's its own big, long discussion that isn't relevant to this course. So, with all that being said, there is one more thing to talk about in the world of conditionals. So we have if, we have else. What about if we want to check something that is not just a single true false statement, right? What if something has 3 different outcomes, like comparing two variables. So instead of doing it this way, the way we have, let's use the last sort of conditional statement here, and we will. So I can comment. I'm going to turn off this print because I don't want to just be spamming myself with this while we're doing it. Oh, I know what I'll do. That will make this actually a little better. I will leave these on, actually. That's all fine and dandy. Let's do a new var3. And we're going to make that var3 read from the console. We're going to allow user input. So we're going to have read, or no, input. And our prompt is going to be enter your own number. And this will also show us a, so once we enter our own number, let's check a couple things. Let's check if it's bigger than var1, if it's smaller than var1, or if it's the same, and we'll tell the user. And then, but one other thing we need to do here, anticipating a problem that might happen, is we need to check to make sure that somebody actually puts a number in the console. So how do we do that? If you think way back to where we were learning about variables and storage types, what did you learn? You learned that you can actually check the type of data that somebody has pulled into or put into the command line. Or sorry, the type of data that gets stored into a variable. So let's first, let's do a check. If var3 type equals, and remember, 2 equal signs to check if this is actually blah, 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 blah. 2 equals is the comparison equality versus the assignment equality. So make sure that you always are using 2 there. You will inevitably put 1 without thinking at some point. You'll just get a bug or get an error from it. But so what are we doing? We're checking if var3 is text. So how do we do that? We would say one way to do it, there are many ways to do it, as with many things in programming, is what did I do here? I said, well, is the type of var3 the same as the type of this random string of text? Right, so if that's true, we can't do any comparison because you can't compare apples to oranges. You can't compare if an apple is bigger than 10, right? It doesn't make sense. Python won't know what to do with it. So we want to avoid trying to do that comparison and getting a bug. So we'll say if variable 3 is text and not a number, we will print I told you to enter a number. And we won't do anything else. We'll just go to done. In theory, if you wanted, you could have this go back now and ask for another input and reassign it. But we're not going to bother. And then we'll say else, so if it is something else, we can now check if it is a if type of var3 equals type of an int, so I'm just going to put a random number in there, print. So I'm going to, instead of trying to write this all in one go, I'm just going to take a quick little breather here and print that is a number. Always, so especially when you're starting programming, you should always try to write bits of code in 1 or 2 lines. If you get ahead of yourself and start writing really large amounts of code, you're going to run into a bug and have things not work right. I can get ahead of myself pretty easily at this point, and just start pumping out big amounts of code. But especially when you're learning, I have a goal here that I want to program to some logic conditional thing for, but I'm going to take a moment and verify that this does what I think it should, right? We're going to get a var3. We want people to enter a number. If they enter text, it should print out that they were supposed to enter a number. Otherwise, it's going to come into this else statement and it's going to check, is var3 an integer? And then it will print that as an integer. Okay. Otherwise, we're going to have an else statement right here. Print that is let's tell them what the type is. Tell us what the type is so that we know. And maybe we can tweak this a little bit. Easy. All right, so let's see what we got. Enter our number, 6. All right, so our first issue here. So looks like input automatically reads in a string. Python is not smart enough to figure this out. So let's tell Python that we want this as a int. So now we're going to run into a slightly different issue. Line 26. Got at most 1 argument, got 2. Oops. All right. So let's do it this way. So we will say if type of var3 equals the type of text. All right, this is a great way to introduce the idea of a try statement. So this is the other sort of conditional that you can get in Python. This is a very modern programming technique here. Old languages did not have this functionality. You had to make sure you didn't get errors. But what is a try statement? Try statement tries to evaluate, instead of checking if something is true right off the bat, what are we running into here, right? We're running into something that is a string, and we can try to convert it to an int. But if we enter something, I will show you how this problem arises. if we enter something that is a string, it will complain at us that it is not a number. So what do we want to do? We want to try to convert it to a number. So let's say var4 equals int var3. Okay, that sounds simple enough. And then we will print var4. Easy. Okay. All right, so we get to the point where it wants us to enter a number, and I'm going to enter 7, and it's going to say, excellent, that's 7. Awesome. All right, so let's try that again, and we will run into our first issue. Apple. Uh-oh, we got an error. We couldn't continue our code. Why? Because when we get to the step where we're trying to convert this var4 as an int version of var3, it's going to say, I don't know how to make an int out of an apple, and then it gives up. And we didn't get into any of our other checks. So what do we do? Well, one thing you can do here is this try. Now what does a try do? It tries to do the rest of your code. Just like an if statement will have a check and go into it, a try just runs right into this tabbed area of code. And if it fails, you need, unlike the if statement, the try statement requires a second a second group of code, catch. Or is it? It should be catch. Right? No. Oh, it's try and catch is C syntax. What is the syntax for Python try catch? Sure, whatever. It's try except. Okay. This is a relatively new concept in programming of being able to write code that can actually experience errors and recover in real time. So I didn't learn these when I first learned how to code, but they are pretty important for making programs that are versatile. Try and then except. Yes, except. All right, so what we're doing here is we're getting some text to var3. If that text is able to be converted to an int, it will do that. Otherwise, let's just take this out of our if statement and the other downside to using an IDE is that it's putting stuff over top of my text that I don't want to be over top of my text. Take that, except I told you to print a number, and then we move on. And let's just print. I will leave that alone. All right. So what will this do? If we get var3 in from this console, if it's a number, it will convert it to a number and assign it to var4. Otherwise, it's going to print that you asked for a number. All right. So let's say 7, and good, it's fine now. But if you do some random string of text, it will say, I told you to do a number. All right. This try except syntax here is extremely powerful, but the drawback is there are ways to write this bit of code using a logic statement that is safer for one, but for two, try except statements are inefficient, right? You have to have a bug, you have to have the code fail to get that try except statement to work. So it's something you generally want to. It's a lazy programming technique, right? This works, and it's good to have try catch statements in your code for things that you know, unexpected errors, so that your program doesn't just die when an unexpected error arises. But really, if you were a god programmer, you know, the best programmer there ever was, you should never use them, right? You should always be able to program something in that's more efficient than and less, you know, you shouldn't ever have to get a bug for your code to work. This should never actually be required for your code. And if you want to see, let's see, I can't think of the way that you would do that without try except at the moment. This shows how far I've come. I learned to code without these, but they exist now, and it's so easy to just go and use them that we will just stick with that. I'll modify the script later after the fact if I remember how, or if I think of a way to get around this issue. But where is it going? Oh, yes. What was all this for? It was so that we can ensure that the input from this here input function that goes into var3 is in fact an integer. Once that is an integer, let's tell the user if it is greater than, equal to, or less than var2 or var1. Why did I end up doing all of this? Why was this whole thing, what was I trying to prompt here? It was that the if-else statement actually has one more key feature, and I will show you it right now. If var1 is greater than var4, we're going to say var1 is bigger. That's why I left that code there. All right, and let's do this for now. Else var1 is smaller. All right, but that's not entirely true, right? If var1 is bigger than var4, this is true. But there is a chance, 1 in infinity, right? There's one number out of all of the numbers that exist in which this is not true, right? When var1 equals var4. So we could have another check in here in this else statement and say, all right, if var2 is equal to var4, we print that it's equal to is the same Otherwise, we know that it is not bigger than, it's not the same, so therefore it has to be smaller than. All right, that's one way to do it. Let's see if that works. So our var1 was 10. So if we're greater than, it should tell us 878. What did I do? If var1 is greater than var4. Oh, I just input var4, sorry. So var4 is, yes, var1 is smaller. Sorry. Let's try doing the same. 10, and it's the same. Excellent. So this technically works, but there's a prettier way to write this using the third kind of, or the one other way feature of if statements, right? So we have if and else, but what if we have more than two cases? What if it's not just true or false? What can we do? We can have what's called an elif, which is a weird Python thing, but there it is. What does that mean? It means if this is false, check this thing. It's the same thing we wrote right here, right? It's essentially a chained if statement, but it does, there we go. It just sort of includes it all at once. So we'll say if it's greater than, do print that it's bigger. If it's equal, actually what I'm going to do here, we'll talk about this in a moment. If it's less than, we're going to print less. Easy. And otherwise, we know that it has to be equal. And I already wrote else, so we will say they are the same. And boom. Okay. So you'll see here something another kind of funny thing about Python. In other languages, you can just write code that does nothing. Python does not like it when you write code that does nothing. So you actually, even though this if statement is still checking something, it's mad that it's checking something and then not. I commented this line out, so it's not doing this. So you actually have to comment all of these out to get the code to work. Little weird nitpicky bits about Python, but there we go. So now we've used this elif, and our code is down to just being this nice little chain of checks. So if I do 6, var1 is bigger because it's 10. All right, that's great. And if I do some random text, I hit enter, you wanted a number. It doesn't do any of this evaluation. So we now have a piece of code that can be pretty tolerant to the user doing something stupid, which is generally good. We want to make code that allows for people to be dumb. But I did say I would come back to something here, right here. So when I said I could check if this is greater than this, otherwise, check if it's less than this. And then lastly, check if they're equal. Okay. I was originally going to copy this equal check and put it right here. And then I decided not to. Why didn't I do that? Let this be your very first exposure to optimization, which is what separates bad coders from good ones, right? Anybody with a little bit of effort can learn to code. What makes somebody a good coder is how good they are at writing good code. And what makes code good generally is how fast it runs and how little system resources it uses. So if you want to be a good coder, one thing you should always be doing is thinking in the back of your mind, if I ran this a million times, how do I reduce the amount of times the computer has to calculate something? That is all optimization is. All right. So if I ran this a million times, I took a million different values and just randomly distributed them. Most of the time, they're not going to be the same, right? This outcome, them being the same number, if they're just random, sure. There's if you had a specific case, maybe it's not always true, but if this was just random, them being the same is the least likely thing to happen, right? So most of the time, it's going to be this or this. And when your code is running, it will get to this line where it makes this if statement. It's going to calculate something here, right? It's going to check. A check is a calculation. It has to actually calculate if these values are the same. If that's wrong, it will move on and check these ones. And if that's wrong, it will move on and do this. If I had put the equality in here, you're going to have essentially you're exposing an additional calculation that the computer has to do. And an equality calculation requires a higher precision than a ranged is it bigger than or smaller than. This is all completely not relevant to this particular lecture, but as we go through these, it's worth thinking about how do you reduce the number of calculations, right, for the computer to do. This is the basis of optimization, and while it seems kind of unimportant at the moment, when we're doing stuff that might need to run a few million calculations, if you have a step that you find you can say, you do two things when you only needed to do one, you're functionally reducing, that step's computation time by half. You'd be doubling the speed of your code for that step. So it may not seem like much, but it adds up over time, and for big pieces of stuff that you have to process, it becomes very important. It's the same reason that you kind of want to avoid using these try excepts, except for when you really have to. If you can't think of a better way to get around it, or there's just something in your code that is innately non-deterministic. I've never experienced that, but it probably exists somewhere. Then you go to these, because if you have try excepts where you could have just put some sort of nice little logic check, your code was always going to run slower and be outperformed by somebody who figured out how to do it without them. So with that all being said, welcome to Making Computers Think. You've done it. This is, in a lot of ways, the bread and butter of programming. If you're very good at understanding large sort of choices that are available and outcomes, and sort of how to manipulate things through those logical operations, you'll be a great programmer. So enjoy it, get used to it. It's functionally the whole point of programming, in that computers calculate very fast, and because of that, they can make logical decisions way faster than a human can. So this is what makes a computer useful in many ways. All right. That's all for that. Enjoy, and I'll see you in the next lecture.